Hi, and welcome back. This is lesson number 9, solving for a variable. So the math that you need for high school or AP chemistry is actually minimal, but it requires a firm understanding of algebra. Yeah, there are things like logarithms we'll get to, but even if I'm going to say something controversial, even if you don't understand logarithms, you can still calculate them in your calculator. Whereas things like solving for variables is not something you can do without using your mind and knowing how to manipulate an equation to rewrite it for a variable, to solve for a variable. So let me share my screen and we'll get started. To solve for a variable in an equation, you must isolate the variable so it is the only thing on one side of the equation. Therefore, you must remove everything else from that side of the equation. To remove everything else, you must do the opposite of whatever is being done to that variable to that side. For example, if the variable is being multiplied by a number, you'll have to divide by that number. And what you do to one side of the equation, you have to do to the other. For example, the equation for density is density equals mass divided by volume. To solve for density, all we do is we substitute our values for mass and volume into the equation. So we take mass and we divide by volume. If I were to solve for mass, I would need to isolate the variable, isolate the m. So if I want mass to be by itself on one side of the equation to solve for mass, I have to get it by itself. Let me say that. And then to get it by itself, right now it's being divided by volume. To get rid of volume on that side, to isolate the variable for mass, since mass is being divided by volume, I need to multiply by volume. And what I do to one side of the equation, I have to do to both. So the volume on the right-hand side cancels out, and we see that mass is equal to volume times density. Now, sometimes people have a lot of difficulty solving for a variable in the denominator. There are a couple ways to do this. I'm just going to do it the way that I was just talking about. There's actually what I think is an even easier way, which I'll go to in a second. But a lot of students think that if we're looking at this equation here, and to solve for volume, they would just get rid of mass. They divide both sides by mass and think that they're solving for volume. But the truth is what they're doing is they're solving for the reciprocal of volume, which is not what we want. We want volume. So the first thing we need to do is we need to get that variable, the variable that we're solving for, we need to get it out of the denominator of the equation. So to do that, I know I want to isolate volume, but I first need to get it out of the denominator. So I'm going to multiply both sides by volume. On the right-hand side, it's going to cancel out. So I end up with an equation that's similar to the one before. Volume times density equals mass. Now, and I actually have this equation written here. Now, to solve for volume, since it's being multiplied by density, all I need to do is divide both sides by density, because since volume, let me backtrack. We want to solve for volume. It's being multiplied by density. To get volume by itself, we would need to divide by density. So what we do to one side of the equation, we do to the other. So volume is equal to mass divided by density. Now, I did tell you that I actually have an easier way to do this when you have something in the denominator. An easier way to get something out of the denominator. So let me go backwards. If I want to solve for volume, the easiest way to do it, you can cross multiply. There are many different ways, but I think the easiest way is just take the reciprocal, just flip everything. So though this equation is density equals mass divided by volume, it's the same thing as density divided by 1. If I want to turn that into a fraction, density divided by 1 equals mass divided by volume. Now, if I want to solve for volume, which is in the denominator, I just flip everything. I take the reciprocal of each side. So this now becomes 1 over density equals volume over mass. Okay, yes, density is in the denominator, but I don't care because I'm solving for volume. So right now I have volume in the numerator, so I just multiply both sides. Volume is being divided by mass, and I want to isolate volume. So since volume is divided by mass, to get rid of mass, I'm going to multiply by mass. And what I do to one side of the equation, I do to the other. Mass cancels out. So I get volume is equal to mass divided by density. So that's how I would solve for a variable that's in the denominator. And if we go back to the last page we're on, it's the same equation. Volume equals mass divided by density. Oops, I didn't mean to do that. And so it doesn't really matter how you do it, as long as you do it correctly. There are many methods is what I'm saying, but you want to make sure that whatever variable you're solving for, you want it isolated. You want to rewrite the equation so that's the only variable on one side of the equation. Now I wrote up these rules and I'm going to go over them, but I'm not sure. I think when I was writing them, I tried to create every case scenario. So a lot of times these steps, not really rules, these steps for isolating variable can be very long-winded when it's a lot easier to show you in an equation. But let me review these. So here are the general rules for isolating a variable. If the variable is inside parentheses and being multiplied by a constant outside of the parentheses, you first have to eliminate that constant by dividing both sides of the equation by it. I'm trying to think of, I think the reason I wrote this, I'm gonna use this equation. Degrees Celsius is 5/9. I'm actually gonna make my degrees Celsius is 5/9. I don't remember these equations. Fahrenheit minus 32. That tells you how often I use it and how often we use it in chemistry, which is not very often, but okay. So if I'm solving for, let's say I'm solving for Fahrenheit. In fact, let me rewrite that. So I think this showing you an equation is going to make it easier to understand the rules. And it's probably what I was thinking about when I tried to write these rules, or when I did write these rules. If the variable is inside parentheses being multiplied by a constant outside of parentheses, so right now degrees Fahrenheit is in parentheses being multiplied by 5/9, I need to eliminate the constant first by dividing both sides of the equation by it, okay? To divide by 5/9 is the same thing as multiplying by 9/5, the reciprocal. So I'm going to do that, and I'm going to do that on both sides. What I do to one side of the equation, I do to the other. So now my equation becomes, it's going to end up being a little small, but here, 9/5 degrees Celsius is equal to degrees Fahrenheit minus 32. Number 2, if the variable is inside parentheses and being divided by a constant outside of the parentheses, that was similar to what we had here. It was actually being multiplied and divided by 5/9. It's being divided by a constant outside of the parentheses. You would eliminate the constant by doing the opposite of dividing, which means multiplying both sides by that constant. Number 3, if a variable or number is added to the variable on one side of the equation, which is what we have here, right? We have the variable and we have, well, it's not subtracted, but, I did this step by step. If the variable number is added to the variable on one side of the equation, you want to subtract that number from both sides of the equation. Number 4, if a variable is being subtracted from the variable that you're trying to solve for on one side of the equation, you need to do the opposite. So what we're doing again is we're isolating for degrees Fahrenheit. Since 32 is being subtracted from it on the right-hand side, we're going to do the opposite, which means we're going to add 32. And what we do to one side of the equation, we do to the other. So the equation for Fahrenheit becomes 9/5 degrees Celsius. I'm going to run out of room, so I'm going to do this on the next line, plus 32. And then let's go on. Number 5, if the variable is in the denominator, multiply both sides of the equation by the variable to get it out of the denominator. I prefer to flip it, okay? I prefer to just flip it. That's it. It saves us a step. If the variable is being multiplied by a number or another variable, divide both sides of the equation by a variable or a number. And if the variable is being divided by a variable or a number, we're going to do the opposite. To isolate the variable, we're going to multiply by that variable or number. You see, it's a lot of steps. I tried to encompass everything in this, but I was not, well, it probably was successful, but I'm sure there are case scenarios that I wasn't thinking of when I wrote this. But I just did this sample problem, but let's do it again. If I were to solve for degrees Fahrenheit, I need to get it by itself. So the first thing is it's inside parentheses. So I first need to get rid of the 5/9. So it's being multiplied by 5 and divided by 9. So what I'm going to do is do the opposite, which means I'm going to multiply it by 9 and divide it by 5. And what I do to one side of the equation, I do to the other. So the 5 and the 9 cancel out. My equation now becomes 9/5 degrees Celsius equals degrees Fahrenheit minus 32. Now we have degrees Fahrenheit on the right-hand side, but 32 is being subtracted from it. To isolate this variable, we need to get rid of the 32. Since we're subtracting 32, we're going to do the opposite. We're going to add 32. And what we do to one side of the equation, we do to the other. 32 minus 32 is 0. My equation becomes degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. Now here's one for you to solve. It says solve this equation for T1. Notice we've got P1, V1, T1 on one side of the equation, P2, V2 over T2 on the right-hand side. So don't confuse P1 and P2, okay? The subscripts mean they're different variables. To solve for T1, I want you to solve this and then pause the video, solve this, and then only come back once you've solved the problem. Welcome back. If you have not paused the video, stop the video, solve it, and then come back. If you have solved it, let me just review it for you. Okay, we're solving for T1. It's in the denominator. Again, these days, I'm a huge proponent of just flipping the equation. Since we're solving for something in the denominator, let's just flip it. That means the denominators become the numerators, and the numerator become the denominators. It only works if you flip both sides. Now it's just really easy to solve for T1 because to get T1 by itself, well, right now it's being divided by P1 and V1. So if I multiply by P1, V1, I'm going to get T1 by itself. I'm going to isolate it. And what I do to one side of the equation, I have to do to the other. So P1, V1 cancel out. My equation becomes T1 equals T2, P1, V1 over P2, V2. And in this packet, I have some more practice solving a variable with Khan Academy. If you're struggling with that, it is a crucial skill in chemistry to be able to manipulate equations and solve for variables. I actually don't have a worksheet on solving for a variable. If I need to make one, I will, but I'm assuming most people come with this skill to chemistry, and if they don't, I will have to supplement that accordingly. Take care, and I'll see you in the next lesson.